In today's tutorial, we'll be building a scene with a swirly psychedelic tunnel. The scene tutorials like this one are focused on building specific types of content, so they don't have as much detail about how everything works. It's more just kind of a walkthrough of how to build a particular thing. If you're interested in more detail, I highly recommend watching the videos in the RayTK intro series. They get into a lot more detail about what's going on and why things do what they do. We're also going to be applying some of the lessons from the recent optimization series as we go, so it will improve the performance of the scene. I'm going to be using RayTK version 0.39, but most of this should also work in the previous few releases in case you're using an older version of Touch Designer. Check the video description for a download link for the toolkit. The scene that we're going to be building is based on a series of rings that form a tunnel. So first, we're going to start by building a twisted ring by revolving a 2D cross-section around the z-axis. Then we're going to blend it with a flipped copy of itself to create some interesting intersections. And then we're going to repeat it along the z-axis to form the tunnel, and use fields to vary the shape along the length of the tunnel. And then after that, we're going to apply some bending and add a material, and then at the end, we're going to do some post-processing to clean up the rendered image. And then we're going to animate some parameters to add some motion. And start by dropping the toolkit talks into your project. I like to do that at the root here outside of the main project comp, because when it's in the same network as all of the operators that you're going to create with it, it shows a lot of these data connections, which I find can be kind of confusing visually. But you can put it wherever you want. I just like to do it at the root. So now that you have the toolkit loaded, go back to wherever you're building the scene. Open the RayTK palette with the Alt-R shortcut. And we're going to type in RayMarch Render 3D. And click that or hit enter on it and drop one of those in there. Then create a null top connected to the first output so you can see the rendered image. So next, select the RayMarch Render 3D operator, and we're going to open RayTK's Editor Tools menu with the shortcut Alt-Shift-R. And then under Add Camera, we're going to choose Look at Camera. And we can actually just keep the default settings on the camera. We're going to hold off on adding a light until a little bit later when we're setting up the material. So with that set up, we can move on to the Ring SDF. That's going to be the surface that the rest of the scene is going to be based on. So there are lots of different ways to create ring shapes in RayTK. There is the Torus SDF, which just kind of gives us like a basic round ring. There's also the Mobius ring, which has some twisting and some kind of edges along it. So lots of different ways to approach this. But what we're going to be doing this time is to take a two-dimensional cross-section and then sweep it around the z-axis to form our shape. And that's going to give us a lot of control over how the ring is laid out in different spots around the axis. So just going to clear these out. All right, so open the palette with Alt-R, and we're going to create a circle SDF. And if you try connecting this directly to the renderer, you're going to get some errors. And that's because this circle is a 2D SDF and the renderer is expecting a 3D SDF, so it doesn't know what to do with that. So what we need is to take this 2D cross-section and sweep it around the axis to make a three-dimensional shape. So we're going to do that with a revolve operator. So with the circle SDF selected, open the Editor Tools menu with Alt-Shift-R. And then we're going to choose Revolve. So that's going to drop in a revolve operator. And now if we connect that to the renderer, suddenly we get something showing up. I'm just going to move things a little bit here. All right, and zoom in here. What we have right now showing up is basically a sphere, and that's because the circle is kind of being swept around, but it's staying at the exact center. So we need to kind of push the circle out to make the ring out of the sphere. So to do that, on the revolve, we can use the radial offset. So if you increase that up, you're going to start to see the ring. So let's bump it up all the way around 1.2 or so. And then over on the circle, let's drop the radius down so that it thins out the ring. So I'm going to go all the way down and stay around 0.03 or so, something like that. So it's real thin, but you can still clearly see it. So the next step is to take this single ring and we're going to produce a set of 6 rings that are kind of going along with each other. So to do that, we can use a modulo polar, which will create repetitions of that cross section. So typing that in there, dropping one of these in here. So we're going to insert that between the circle and the revolve. So we're not seeing anything yet, and kind of a similar thing to with the revolve, we need to spread out the different copies of that circle. So over on the offset parameter, we're going to increase the first part up to around 0.5. So that's going to spread out those cross sections. So now we have a set of kind of 6, because we've chosen 6 repetitions there, so we have a set of 6 kind of concentric rings like that. So next what we're going to do is we're going to twist that whole cross section as it goes around the axis so that we get twists in the ring. So we can do this with a rotation in the modulo polar. So on this rotate parameter here, if we increase that or change it, however, it's going to basically roll the cross section around. So we want, instead of just using one amount of rotation for all of the parts, we're going to use a field to vary that as it goes around that center axis. So select the revolve, and then we're going to open the editor tools with Alt-Shift-R, and then under reference variable, you're going to choose normalized angle. So that's going to create a variable reference operator here that will produce values going from 0 to 1 as it goes around the axis. So that way the two-dimensional cross-section can change its properties at different points around that axis. So let's try connecting that variable reference up to the rotation field input on the modulo polar. And when you're doing this, make sure to mouse over the different inputs to make sure that you're getting the right one. In other versions of the toolkit, these inputs might be in a different order, or there might be some new ones or fewer ones. So it's important to mouse over and just make sure that you're connecting to the right one. All right, so when we do that, we see basically nothing change except like little tiny discontinuity over on the side there. So that's because the rotation is supposed to be specified in degrees, and we're basically just giving it values going from 0 up to 1 degree, so that's only a tiny amount of rotation. And that's why things are kind of offset there a little bit. What we need to do is to scale up those values to a reasonable number of degrees, and there are a bunch of different ways that we can do that. But we're going to go with applying a wave instead of just rescaling the values or something like that. So I'm just going to give myself some room here. So with the variable reference selected, open the editor tools with Alt-Shift-R. And then under Apply Wave, we're going to go with Ramp. and then we can connect that to that rotate input instead of the variable reference. So now on the wave field here, we're using a ramp, and it's actually not doing anything different, although it did kind of swap where that break is, but it's still just going up to a value of 1. So what we need to do is increase the amplitude of the wave here. So let's just start bumping that up and keep going up until you hit 60. So once you hit 60, you're going to see things kind of looping smoothly there, whereas if it was, you know, even a few degrees more or less, then you get that break on the side. So the reason that this is 60 is because over on the modulo polar, we're using 6 repetitions. There's basically 6 parts in that cross section. So we're currently rotating by like 1 part's worth. If we want to be able to change that easily and not break that, we can, on the wave field, we can use an expression. So on the amplitude, let's replace that 60 with 360 times OP, parentheses, quote, and modulo polar 1 with capital P, dot par, dot repetitions. And it helps if you spell repetitions correct. There we go. And so it's actually not times, it's divided by. There we go. Okay. So this is always going to be 1 ring's worth of rotation, regardless of how many rings there are. So, you know, you could change the number up to, you know, something larger and you're still going to get the same thing. But let's go back on to 6 there. So that gives us basically 1 step of rotation around, but if we want to have multiple, we could do something with the period on the wave. So if you drop that down to 0.5, then you're going to get 2 repetitions. If you go to 0.25, you'd get 4, and so on. So basically any whole number divided by, or 1 divided by any whole number, rather. So that's one option for doing that, but I'm going to go back to a period of 1. I find it to be a little bit easier to work with if we, instead of changing the period there, we just multiply the values that are coming into it. So select the variable reference and then open the editor tools with Alt-Shift-R, and then we're going to go with Rescale Field Simple, and then connect that up to the input on the wave. So now on this rescale float field, we now have this multiply parameter, and if we increase this to any whole number, then we get that number of repetitions of the twist. So feel free to set this to whatever you want, although I'm going to go with maybe like 8. So next, we're going to use a similar approach to vary how much the individual parts of the ring are spread apart at different points around the axis. So similar setup to what we did here with this field here. Now we could actually just, reuse this existing variable reference here for another field if we want, but just visually to keep the network clean, I'm going to make a new one instead, and because it's just a variable reference, that has basically no performance impact using multiple versus 1. So then let's go over to the revolve and then open the editor tools with Alt-Shift-R, and then under reference variable, we're going to go with normalized angle. Go over to our revolve here. I really don't like it when the network editor does that. But anyway, let's try connecting this up to the offset input on the modular polar. And again, remember to mouse over, make sure you're getting the offset field rather than one of the other inputs. So we do that, we're going to get this error output showing out of the renderer. And due to a bug in this version of the toolkit, it should be showing you an error message on the modulo polar here, because that's where the error is happening. So future versions, it should be showing that error, but this one, it isn't. But the reason this is happening is because that offset, if we look at the parameter there, it has 2 different parts to it. So we're only really using the first part, but it does still have two values. And so the input that it gets, it expects it to be a vector so that it has a number for each of those parts. And currently this variable reference that we're doing is just producing a single number, going from 0 to 1 around the axis. So that's not going to work there. So what we need to do is we convert that single number into a vector. And since we're really just only using one of the parts, we don't need to do any like special scaling or anything. We can just open the palette with Alt-R and then create a float to vector and then insert that between the two. And then for the Y part there, we're just going to set that to 0. Do the same thing for Z and W, although those aren't really being used, but just for cleanliness. And then we keep that part source for X on input 1, which is that variable reference there. So it's basically doing the same thing that we have here, where we're using a value in the first one and then just leaving the second at 0. So that gives us a vector, but we need to work on the arrangement of that variation around the axis. So let's give ourselves some room to do that. All right, so right now we're just kind of basically passing that 0 to 1 value straight through, which is why we're getting, them really close together here, and then it increases up to that, maximum amount of separation, and then it goes back. So what we want instead is to use a sine wave that will give us a clean number of kind of going in and out without having that hard cutoff there. So with the variable reference selected, let's open the editor tools menu with Alt-Shift-R, and then under apply wave, we're going to go with sine this time. And then connect that up to the float vector. And note that if we didn't have the float vector there, then we'd have that same issue since this wave field is just producing a single number. But now that we have it, we're all set, and it's just using it for one of the parts of the offset. And one thing to note is that when we are using the parameter as well as the field there, it basically adds the two values together. So over on the field, we want to drop down the amplitude there to around 0.2 or so that we get just like a little bit of variation without it totally collapsing. So now we can change the phase, and it's going to kind of like shift that spread or collapse pattern around that axis. And to get more than one repetition of the wave there, we're going to do the same thing with, instead of changing the period on the wave, we're going to add a rescale before it. So select the variable reference, open the editor tools with Alt-Shift-R, and then rescale field simple. Then hook that up to the wave field, and then we can use this multiply here to go up to any whole number. So you could do a larger one if you want, but I'm just going to keep it low at 2. So now over wave field, if you change the phase, you're going to see how that's kind of shifting that two portions of that pattern of expanding and collapsing around the axis. So we're going to add some animation to this later on, but for now we'll just leave it at 0. Before we continue, let's apply some optimization to what we've created here. This is going to help improve performance and stability, especially as the scene becomes more complex later on. In the recent optimizations video series, I get into a lot of detail about how these techniques work and where to apply them, so I recommend checking that out if you want a better understanding of all of this stuff. But for purposes of this video, just kind of follow along with these parts. So let's go over to the wave field that we're using for the rotation there. And on this one, we're going to go to the wave type parameter here, right-click it, and choose Toggle Read Only. And that essentially bakes that setting directly into the shader and simplifies the code. So that approach doesn't work the same way for all parameters, but this one in particular, the wave type on a wave field, is one of the places where it's especially useful. And then we're going to do the same thing on the other wave field that we created there that's doing the offset for the spread. So again, go to the wave type here, right click that and choose toggle read only. And that's it for optimizing this part, but we're going to be doing more of this as we go along in the upcoming sections. So we've set up a nice twisted ring, which is fine, but could be more interesting. So let's make 2 copies of it flipped along the z-axis and merge them together. All right, and we're going to be doing that by inserting a flip operator after our revolve. So just open the palette and create a flip and insert that between that revolve and the renderer. And I'll zoom in just a sec. So let's then change the axis from X to Z. So right now, by default, what this does is just flips everything along whichever axis you have selected, so Z. But we can use this merge type parameter here, change it from none to smooth union. So then what that's doing is taking the 2 versions, so one that's kind of the regular right way around, and then the other one that is flipped, and it's then merging the 2 of those. And we can use this merge radius here to control how much they kind of melt into each other. And then we can use the shift here to kind of move the 2 closer or further away. So I'm going to go with a shift of around -0.2 and then a merge radius a bit higher to around 0.4, something like that. So don't spend too much time on tweaking these parameters since we're going to be applying a whole lot more stuff on top of it. So things are not going to appear quite the way they are here anyway. Now, it's important to note that this merge option on the flip operator can have a significant impact on performance, because what it does is basically repeat all the work of all the things connected to its input twice. So that can definitely have a performance impact. Now, we can optimize things just a little bit by selecting our flip operator, and then on the merge type here, right click that and do toggle read only. So this is going to kind of bake that type of merging into the shader. It's not going to do anything about duplicating all the work of the inputs, but for now, that's not really going to be an issue since we aren't animating anything yet. But later on, once we start to add animation, you start to actually get, a meaningful frame rate, then you may notice that things are slow, and if that case, then you can toggle it off to kind of save some performance. Next, we're going to repeat this ring shape along the z-axis to form a tunnel. So open the palette and create a modulo 1D. And then we're going to insert that after the flip. And then on the modulo 1D, we're going to change the axis to Z. And then increase the size to kind of spread them out a bit. I'm going to go with something like 2.5 or so. And now we can use the shift parameter here to kind of move everything forward or back. Later on, we're going to be adding some animation to this to add that kind of infinite motion. But for now, let's just leave it at 0. And for a little tiny amount of optimization on this, just on the axis, right-click that and choose toggle read only. So which parameters this works on is kind of different for different operators, but I get into more detail about that in the video in the optimization series. So now that we have this shape being repeated to create the tunnel, we can use a variable from that operator, the modulo 1D, to vary the properties of the different repetitions of the ring along that axis. So to do that, select the modulo 1D, and then open the Editor Tools menu with Alt-Shift-R. And then under reference variable, we're going to choose cell index. So then to apply this, to the twisting, we're going to make some changes to our field that's connected to the rotation input. And I'm realizing I swapped two of these, so all right, we're going to move stuff related to the spread up there and then rotation down here. So over on the field that's controlling that twisting or the rotation, we're going to take this variable reference here, and what we want to do is add another wave that is based off of which repetition it is. So with that variable reference selected, we're going to open the palette with Alt-Shift-R. Under Apply Wave, we're going to choose Sine. So then to combine these two, let's select both of the wave fields there, open the editor tools with Alt-Shift-R, and then under Combine Fields, we're going to go with Add. And then connect that combined fields up to the modular polar instead of the wave field. So we're not seeing anything, and again, that's because they're dealing with degrees there, so we want to bump up the amplitude of the sine wave to something higher, like 90. And then we still aren't seeing anything, and that's because the cell index variable here is producing values that, you know, start at 0 for one of them, go to 1, 2, 3, and so on. And with a sine wave with period 1, they're basically all getting the beginning of that sine wave, so they're all getting the same value. So for the period, let's bump that up to something like 6 or so. So now we change the phase there. We're going to see how we get that kind of twisting, moving forwards and backwards across the copies of the ring. So later on, we'll add some animation to this, but for now, we'll just leave it. So let's optimize things a bit here before we continue. So on that first wave field, we already did it, but for the second one, let's right-click the wave type there and then just do toggle read only. And then on the combined fields, switch on this optimize parameter. And that is pretty similar to doing that read only trick, just with some special optimization for this particular operator. Next, let's vary the waves that we're using to kind of control the spread of the different parts of the rings across the instances repeated on the z-axis, or not instances, but kind of repetitions, since they aren't actually repeating the work. But get into that in more detail in the repeaters video in the intro series. So then we're going to go over to our modulo 1D and do this again, where we open the editor tools with Alt-Shift-R. Under reference variable, we're going to choose cell index. Again, we could reuse the other one, but just for clarity of the network, I'd like to have a separate one. With that variable reference selected, open the editor tools again with Alt-Shift-R. And then under Apply Wave, for this one, we're going to do a ramp. And similar to with the rotation field that we used there, we want to spread this out over the instances. So let's go with something higher, like 8 or maybe 10. And then we're going to use this ramp to shift the phase of the waves that are doing the spreading. So to do that, we're going to take the output of this wave and we're going to go over to that first one and find its phase field input and then connect it up there. So now we've got a setting here on the phase there that we can move, and that will apply that shifting, just kind of increasing it for all of them, but each one is sort of offset from the one before it. So again, this is going to be a spot where we're going to add some animation later. Now we're able to use a ramp here because a shift on the phase for like 0 or 1 of 1 is basically the same thing. So when it the ramp goes up to 1 and then wraps around to 0, then it basically just smoothly repeats the pattern. So again, let's optimize things a little bit. On this other wave field here, we're just going to right-click the wave type to toggle read only. Next, we're going to add some bending to the tunnel head of the camera. So we'll be doing that after the modulo 1D by inserting a bend operator. So connect this up here and then connect it to the renderer. And then we want to change the direction to along Z towards X. So that's going to bend it side to side along the kind of depth axis. So now on the amount here, we can change that. And you'll notice how there's an area where it isn't really doing any bending, and then it's applying a lot of bending before and after that. So what we want, instead of doing it kind of in both sides of that, we're going to change the side here to negative. So now it's only going to bend that front portion of it, and we're going to basically keep the spot where the camera is without any bending so that we don't have to worry about the camera intersecting anything. And if we go over to our modulo 1D and try changing the shift there, and see how it is applying that twisting kind of after that repetition, so we get the entire twisted series of rings bending side to side. But just going back to 0 there. Then on bend here, so you can try larger values, but notice how things get really distorted and weird in the background when you do that. So you can end up even getting like multiple sort of reflections of things appearing, and things get kind of bent out into craziness. So I'm going to keep this relatively low to maybe like plus or minus 0.4. So that's about as much as we're going to do there. Maybe even drop it a little bit closer to 0, like 0.3. And we're going to do some stuff later on that's going to kind of eliminate those areas in the back where it's showing more of the bent tunnel. Next, it is time to set up our material and the light. With the bend selected here, we're going to open the editor tools with Alt-Shift-R and then choose Apply Modular Material. And then take that, move it, and connect that up to the renderer. And then just move this down here. So move this over here. So right now we aren't seeing anything, and that's because we need to provide it with some different shading techniques so that it can apply color to the surface. With that modular matte selected, open the editor tools with Alt-Shift-R, and then under Add Diffuse, we're going to choose Oren Nayar, and then go to select the modular matte again, open the editor tools, and then this time we're going to do Add Specular and GGX. And before we start refining the settings there, let's add our own light instead of using the default one that's built into the renderer. So go over to the renderer and select that, open the editor tools with Alt-Shift-R, and then under Add Light, we're going to do Point Light. Then on the light, let's move it a bit over on the side to maybe like 1 on the X, and then a bit up to about 2 for Y, and then for Z, we're just going to push it forward a little bit to like negative 0.5, something like that. So that gives us some kind of nice variation in the amount of light that's hitting different parts. Now let's go over to our diffuse. And for this one, let's increase the roughness to 1, so that kind of reduces some of the sharpness of the shine there. Although most of the shine is in the specular, but there's a little bit in diffuse too. Then for the color, let's go with something that's close to white, just like a little bit of pale blue, something like that. And then over on the specular, change the color to something more saturated, like maybe an orange. And then we're going to drop down the roughness. So it's going to kind of tighten up those shiny bits. So maybe put that to something around 0.3 or so. And then for the Fresnel, we'll just bump that up to 1 to kind of brighten things a little. And that's it for kind of the standard shading here. So before we move on, let's optimize things a bit. So on diffuse contrib, I'm going to go to the method parameter, right-click that, do toggle read only, do the same thing on specular contrib. And this is especially effective on these particular operators because they involve a lot of code to support all the different types of shading that they can do. And doing this sort of locking it as read-only has it just bake in only the parts that it needs. So now it's time to add in the iridescence, which is going to be responsible for most of the coloring of the scene. So open the palette and create an iridescence contrib. And then we're going to connect that up to the next available input on the modular mat. So this adds rainbow highlights to the areas that are facing kind of almost perpendicular to the angle they're being viewed from. So basically the kind of sides or edges of things. And then it uses the direction that it's facing kind of around, out from the center to figure out what color, what part of the rainbow pattern to apply there. So let's dial in how much those highlights are spread out and smoothed out. So in future versions of the toolkit, I might change this, kind of make it a little bit simpler to work with spread, but for now we've got this. So for the first part, let's drop that down to like 0.15 or so. And then for the second part, let's drop it down a little bit more to like 0.75. So that is basically tightening the area around which it's applying that highlight, and then also kind of tightening the range over which it fades from full highlight to none. So now it's time to fix some of the weirdness in the far distance, and while we're doing that, apply some really interesting distortion. So before we do that, let's go over to our bend and then just switch that off for now. So now we can see, if you zoom in, to the center there, things get kind of messy in the middle. So we can do this fix and also distortion by kind of abusing a feature of the Raymark renderer. So let's go over to the renderer, select that, go over to the settings page here. And again, in future versions of the toolkit, I might rearrange this, but just look for something called distance correction factor. So the distance correction factor is intended for fixing some errors that can sometimes happen in Raymark scenes. So the details of this aren't necessarily important to play with it, but just in case you're interested. So when the renderer is marching along the rays into the scene to find out where it's going to hit something, it keeps asking the SDF how far the closest surface is, and so it knows how far it can step without hitting it. And so it does that up until it actually hits something. But in some cases, some SDFs will produce answers that can cause the ray to step all the way through a surface and out the other side. And when that happens, you can get some kind of tearing or gaps in surfaces. So the distance correction factor is a way to deal with that by multiplying the distance that the renderer steps along the ray. So with a default setting here of 0.5, it's only going to step half the distance that it knows it can, and because of that, it's going to kind of catch surfaces more accurately. Now, taking smaller steps means performance cost because it also means taking more of them. But it's not a huge difference, so we can kind of play with that a bit. So if you try changing the setting here, if you go higher, you can start to get some places where you'll get some kind of gaps or cuts through surfaces. And if you go lower, then if you go too low, then things kind of start blending together and you get some really interesting effects going on in the areas between surfaces. So the exact reasons why it behaves like that, I'm not entirely sure. If you have a theory, I'd be interested to hear it. But let's just kind of tune it until we get some interesting patterns there. So if you go all the way down, everything merges together and you kind of lose the coherence. But let's go with something where we're getting some nice rings in those inter-shape areas, those gaps. So maybe something like 0.08 or so should give us a good blend. And that's also kind of cleaning up the area in the middle by smoothing things out there. So we get, distortion, but it's like not noisy, messy stuff. It's more smoothed out, which is nice. Before we move on to animation, let's clean up the image a little bit. So there are a bunch of places in here where things get kind of pixelated and noisy. So you can zoom in within a top viewer by activating the viewer there and then mousing in like that, or like holding the middle mouse button and moving the mouse up and down. So if we do that, then we can see how there are some kind of hard pixelated edges there, and there are places where we get these kind of like little bits of color that are not matching what's around them and so on. And your first instinct here is probably to increase the anti-aliasing on the render. Before you attempt that, I recommend saving, because occasionally there can be some stability issues and crashes that can happen when changing that. But I don't recommend using that approach, and that's because it's going to have a really significant impact on performance. Now, in the first video in the optimization series, I get into a lot of detail about why that is, but in short, an anti-alias setting of 2 means doubling the entire work of every part of the shader, and a setting of 3 means tripling it and so on. So that gets real costly real fast. So instead, we can try some cheaper alternatives that involve post-processing on the images that are coming out of the renderer. So the first one of those that we're going to try is the anti-alias top. So let's create one of those and then insert that after the null coming out of our renderer. And then you can add another null if you want to set the viewer on that, which is basically what I've done here. So anti-alias here is helping a little bit. So if we toggle that on and off, you can see how it is smoothing things out a bit. It's not catching everything, but it's definitely helping. And this is doing that based on looking at the contents of the incoming image and kind of trying to detect where edges are and smoothing those out a bit. And that ends up being a lot cheaper performance-wise than doing it in the renderer, where it's basically repeating the entire render process multiple times and blending the results. So that helps a bit, but we definitely have some more stuff that we need to clean up here. So what we can do is make kind of our own handmade variation of that concept by identifying pixels where there are edges and then just blurring those a bit. There are different ways that we could try to identify where the edges are. If we just do like an edge top on the color output, then things are gonna get kind of, it's gonna treat basically any change in color as an edge, which is way too much of the image. It is probably including the parts that we want, but tons of other stuff too, so that's not gonna work. So another option would be to use the depth map, but I found that using the surface normals actually produces a little bit better of a result in this case. So to do that, let's select the renderer, open the editor tools with Alt-Shift-R, and then under select output buffer, we're going to click normal. So that's going to create this render select here that is going to access those surface normals. So creating a null top connected to the first output, let's just look at that. So this is taking the direction that each surface is facing, so at whichever pixel we're looking at, and it's storing the amount that it's facing in the x-axis in the red channel, and then green is y, and then z is blue. So one option to go from there to identify edges is just to kind of do that on just the red channel, and then do it on the green channel, and then do it on the blue channel and combine them all. That kind of works, but I found that the results are a little bit better if we just do it on the hue. So that gives kind of a rough approximation of places where the direction is changing. So to do that, let's create an RGB to HSV top, and then we're going to insert that after the null here, and then drop down an edge top and connect it to the output. And then instead of the luminance, we're going to change the select there to red, so it's just doing it on the hue. So now that we have identified the areas where there are edges, let's apply blurring to them. So if we create a Luma blur top, and then we connect the anti-alias to the first input, and then that edge to the second input, and then look at the result of that. So that is smoothing things out in the places that we've identified as edges. So we can use the white filter width here, and that will control how much blurring it's going to apply in those areas. Now, depending on all the specific settings that you've selected as you've been going along here, you may encounter some issues where there's a bug in the Luma blur operator. And it's not finding one here, but there can be points where you get these kind of like black squares that pop in and out of existence that get larger when you increase filter width. So the way to deal with that, so I'm just going to go back to 16 there. Way to deal with that is to make sure that the stuff coming in the first input is stuck to a 0 to 1 range. So let's create a level top, and then just insert that after the anti-alias. And then we're going to change the clamp input to 0 to 1. And that seems to fix it. If not, let me know. I'd be curious to see if there are other options, but yeah, this tends to work. And when that happens, it can be particularly annoying because it's not always there and it'll just pop up randomly, but this seems to fix the issue. Now, if we zoom in and look around here, we can see that there are still some issues. It's definitely helping, and so if you try like bypassing the Luma blur there, you can see how it's somewhat helping, but also there are some spots where it's missing. And that's happening because it's doing the right thing directly on whatever pixels it's identified as edges, but it's not doing anything on the pixels that are like right next to that. So to do that, we want to kind of expand our edges a little bit, and we could do that with sample step, but I think this approach gets a little bit cleaner, so we're going to apply some blur. So just insert a blur between the edge and the luma blur, and there we go. So that kind of smooths out where it is or is not applying the blur. So you're blurring the mask of the blur. A lot of blur. All right, so that is basically it for that cleanup. So the last step is to add some animation to some of the parameters in the scene to give it some motion. So let's first apply it to the field that is controlling the spread of the rings. So just going to go over here, and we're going to do the first wave field here, the one that's the sine wave, and we're going to select that and then open the editor tools with Alt-Shift-R. And then under animate with speed, we're going to choose phase. And then we can adjust the speed there. So maybe drop that down to like something, 0.2, something like that. It's up to you. You can use any combination of like the numbers there and the multiplier. It'll just combine the two, but I like to use this first one to kind of give the slider a more useful range. So drop that down however you like, and then we're going to do something similar for the twisting kind of rotation. So let's go over to that second area where we're building that field for the twisting or the rotation, and we're going to go to the second wave field here, the one that's a sine wave that we're kind of applying across the instances that are not instances, but repetitions along the z-axis, and select that, open the editor tools with Alt-Shift-R, and then under animate with speed, I'm going to go phase. And again, dial the speed however you like. I'm going to slow it down a bunch so it's a little less chaotic. And you can also try, flipping the direction that things are moving in. So, making the wave move forward or backwards or however you like. As you are adding the animation here, we're now going to be, rendering multiple frames. So you're actually going to get to see what the frame rate is. And if you are getting a low frame rate and that is an issue, then you can go over to the merge and switch that off, and it changes things, but not, you still get something out of it. So that should definitely improve performance. And then last, we're gonna go over to the modulo 1D and select that, and then open the editor tools with Alt-Shift-R, and then under animate with speed, for this one we're going to do shift. And that will have the tunnel kind of moving forwards or backwards, just at whatever rate you specify. You can also use the reverse here to make it come towards the camera instead of away from it, and then adjust the speed, but I actually kind of like the speed of 1 there. And that is it for now. So to recap, we are creating a ring by taking a two-dimensional circle SDF and revolving it around z-axis, and we're spreading out multiple repetitions of that using a modulo polar to create multiple concentric rings, and then we're using some fields that vary how much the different repetitions of that circle are spread apart to kind of spread apart the rings, and also another one to twist it as it goes around the axis, and we've got some more fields varying stuff there. So then we are taking that combined kind of multi-ring and flipping it along the z-axis and merging those two together with smooth union. So that's where we get the kind of shapes melting into each other. Then we are repeating the whole thing along the z-axis with a modular 1D, and then we're applying our bending, which we actually turned off earlier, so let's go over to that and just flip that back on. And that is bending the end, the kind of distant end, side to side. Then we are applying a material, a modular material, using kind of a standard diffuse and specular combination, along with iridescence that's doing those rainbow highlights around the sides of things. Then we are rendering it out and using some post-processing to clean up some of the rough edges with an anti-alias top, and then our own kind of approximation of that using the surface normals with an edge to identify edge areas, and then blurring those out with a luma blur. There is a bunch of different stuff that you can do from here. You could try using another field to vary the thickness of the rings as it goes around, make kind of little bloops instead of solid rings, or you could try a different type of cross-section shape, or change the shading to focus less, or I guess even more, on the iridescence. So, you know, without iridescence it gets like that, so which is still cool in kind of a different way. So you could try different ways of shading it, or use fields to vary the rings, you know, repeated along the z-axis, and so on. So I look forward to seeing what you all do with this one. And if you post on social media, use the RayTK hashtag. And at least on Instagram, because their hashtag search is kind of broken, you can tag me directly if there's stuff that you want to show off. I am considering doing a second part of this video that consolidates the parameters for the scene so that they can be hooked up to MIDI controls or audio reactivity or whatever. If you're interested in that, let me know in the comments. And thank you for watching. If you want to support RayTK development, subscribe to my Patreon. You'll get early access to tutorials, scene file downloads, and lots of other stuff. And even if you don't want to pay, you can also just subscribe for free as a way to get announcements about the toolkit. And feel free to reach out if you have any questions. I'll put links in the description for that, different ways to reach me. And anyways, thanks for watching, and make sure to like and subscribe.